Happened too. I took geometry in high school and learned nothing. All right, let's get to it. So we're on number 19. Stephen tells me. Let's move forward from number 19. So, all right, so we have a bunch of, oh yeah, this is like a little trick question. Okay, this is weird. So they're adding up sine 40, sine 135. So there it is. This one's really like a trick. So let me just show you the trick of adding up all those sines. Like, how are you supposed to do those without a calculator? Remember, I'm going to ask you when we take the exam, whenever that is, week after next on Monday the 4th is our exam. Yeah, let me put up what our homework is. So 6.2 will be due on Monday. Raul wanted some homework over Thanksgiving, he was saying. So 6.2 is due on Monday. So anyway, our exam is on the 11th. No, that's our final exam. The 4th is our exam. Anyway, when we get to our exam, part 1 will be no calculator. All the trig will be on the no calculator part. Well, not all, almost all the trig.
No graphing?
So no calculator at all. Yeah, just like the last exam, how part 1 was no calculator at all. So yeah, so I do want you to be able to do that with no calculator at all. That's kind of tricky with no calculator at all. Because 40 degrees, that's not one of the angles we know. Right? We know 30 and 45 and 60. How are we going to do 40 and we know 135, but then add all those up with no calculator?
No.
Let me start moving through it. It's a trick. And as soon as you can see the trick, just yell out the answer.
Just add them all up and then look for the total number?
Yeah, no, that's not true. I hear what you're saying. So in other words, Lewis, you're saying just add the degrees. You know what you want to think? Let me help with that. Because that's not a bad thought. And how is it I say to you right away, no, that's not true?
Oh, because they're not the same numbers. They're all different, right? Because sine of 135 isn't the same as sine of
They're different, but Luis is putting forward the general thought, can we add, is that sine 180, right? That's the general idea you're saying, right? Can we just add the two angles? Well, whenever I think a thought like that, I test it. Because there's, like I've said a couple times to you, there's just too many rules in math and science to go around having them all memorized perfectly. That's not how people do math and science. It's about testing yourself, learning to become a self-critical tester. So if I thought that same thing, because that's a good thought. If I looked and go, hey, maybe I can just add the angles, I would stop and go, well, is that true? And I would think about a really simple, like 90, not something hard, but 90. I go, if that was really true, if you could really add the angles, then this plus this must equal that, do they? Is that true? What is the sine of 90? It's, remember, we can get the unit circle thing. Yeah, you guys are right. What's 1, right? Isn't the sine of 91?
Yeah.
Here's 90 degrees. Remember, cosine is 0, sine is 1, unit circle there. Sine is 1. So this is 1, and this is 1. And what's the sine of 180? Go back to the thing. Sine of 180 is right here. This is cosine. This is sine. Sine is 0. So 1 plus 1 equals 0. So it's not true, huh? So you cannot add the angles. So you see how you do that, though? I don't go around with a catalog in my head and go, when it comes to trig, angles may not be added. But they, there's too much. You can't do math that way. There's just too many rules. But instead, you test them. So I hope you learn to do that. That's how you survive math and science, really. All right, anyway, not by this great memory thing. So anyway, so that isn't going to work. It was a good thought, but it's just not going to pan out. So what I suggest is let's start putting these things on the unit. Let's just get a look at them. Just get a picture. So 40 degrees. Where's 40 degrees?
Between
45.
Yeah, it's about right there. It's just below 40, just below halfway, huh? Because 90 straight up, 40 is just below 45, just below half. Okay, great. So what? Oh, and what is sine?
The y values.
The y value, the height. The height, right? So sine is that height. So when they say sine 40, remember, sine is y value, height, right? It's the y value up to 40 degrees. All right, let's do 135. Where's that one?
Exactly in between.
Exactly in between. It's right smack in the middle. And so, and the sine of 135 is, again, the height. So it's some positive number, right? Wouldn't you agree the sine of 40 is some positive number just below halfway up, just below half, right? Because we know all the way up's 1. right? This is 1 all the way up, right? It's a unit circle, 1 circle. So this height is just below half because it's just below the middle. Some number, I don't know what it is, but it's something just below 0.5, just below half. And this, what's this? It's right in the middle. So it's exactly half, isn't it? I know this one's plus a half. That the sine is the height again, right? Cosine is x, sine is height. Okay, so what? All right, I got a half and I got something I don't know. I'm still no good. Keep going. What's the next one? 220. Where's 220?
Closer to the midpoint, but a little bit to the left.
It's 180 and right.
Plus 40.
Plus 40. 180 plus 40 is 220. Right? And what's the sign? The height, in this case, the depth.
It's negative.
It's negative. Anybody seen the, I'm waiting for the final answer to the problem
So
now.
it's going to even out to 0?
0. Do you see what's happening here? Do you see how this is going to balance that? Because they're both 40 degrees off the axis?
Yeah.
Whatever positive height this one is up to 40, this is negative, that same thing. I don't know what either one of them is, but I know they're the same. This is up and this is down, same amount off the axis. So whatever they are, they're the same, and one is positive and one is negative. Cancel, done. For those two, and then the last one, because we still have this guy. What about him? Well, the 315 is exactly in the middle here, which means he's down half like he's up half. So everything cancels. So the answer is a big 0. And you don't need a calculator. They're wanting you to spatially see the unit circle. And remember that sine is heights. And so when you go 40 degrees and 220, that's a 220 there, kind of scribbly. 220, those are both up and down 40 from the axis. So his up and his down, positive y, negative y cancel. Then he's up a half, he's right in the middle. And he's down, 315 is down a half, right in the middle. Those two cancel. So this one cancels this one, and this one cancels that one. It's a big 0. By picture. I don't even know what they are, the numbers, at least 2 of them, but I know they cancel because they're in the same spots. All right, that's what they're going for in that one. All right, so f of theta equals tan theta equals 4. Find, okay, select the correct. So what do we do on this one? They're saying f of theta is a function, and it's just tangent. And they're saying it's 4. Find f of theta plus pi. Probably the language is hard for you there. Let me just help with that. They're saying, hey, tangent of theta is 4. That's what they're basically saying. They don't even need that f thing, whatever. Tangent of theta is 4. And then they're going to say, find f of theta plus pi. Well, that would be tangent of theta plus pi. You with me so far? Right? Because if f of theta is just tangent, then f of theta plus 4 is tangent of theta plus 4. So if tangent of theta is 4, what's going to happen when you go up by pi? Well, do you remember the, what's it called? They're wanting you to do the cycle, the period, that's the word, the period of tangent. Anybody know the period of tangent? Meaning the cycle, how long till he starts repeating answers? It's pi. Every pi, tangent and cotan, repeat answers. The period for sine and cosine and cosecant and secant is 2 pi. They repeat answers every 2 pi. So the whole purpose of this question is to test if you know the cycle until all the values repeat. So what that means is if you're at any angle theta and the answer there for tangent, if the tangent of any old angle theta is 4, if the tangent is 4, and you go pi further down the line, it's still going to be 4. It's going to repeat. That's what it means to be on a cycle, right? Does that make sense? If I said, hey, I'm going to raise my arm and lower my arm every 3 seconds in a repeating cycle, and I said, okay, wherever my hand is now, where's it going to be 3 seconds later? Exact same height. If I'm repeating myself every 3 seconds, then 3 seconds down the line, it's going to be exactly the same height. That's what a cycle means, right? And so if the period, the cycle for tangent is pi, if you have an answer of tangent and you go pi further down the line, it's going to be the same height. That is what that means. Is that good? So it's just, do you know the period of, so you want to put on your 3x5 card for the next exam, the period of tangent and cotan is pi, the period of the other 4 trig functions is 2 pi. All right, I'll move with that. The answer was just 4 on that. So here was the answer. It was just 4. The value didn't change. It was 4 before, it was 4 after. Okay, let's see. So f of theta is sine, g of theta is cosine. Find the exact value of negative g theta if theta is 45. So what is g of theta? G of theta is cosine. And so they're saying, what if we put a negative in front? Well, okay, then you'll have negative cosine. And in particular, they're saying, and then they want theta to be 45. So they want negative cosine of 45. So that's all they're saying, just a bunch of fancy language for them to say, can you tell us what negative the cosine of 45 is? See how I tracked that through? So g of theta was cosine, so negative g is negative cosine, and they said put in 45. So go to 45.
Negative 45?
Right there.
No, just regular 45. Whoops, not sine first, cosine first, huh? Cosine, sine root 2 over 2. So this would be negative. Yeah, the good question on that. The negative's on the outside. It's not on the angle. So negative root 2 over 2. That good? Just looked up 45 degrees in the unit circle. Negatives in the front. Like that. It's all as well. Okay, so let's try. Okay, so they're saying, this time they're saying f of theta is sine. I don't even know why they give me g. Who cares? They're not even asking me anything about g. They just say f of theta is sine. And then they're saying, find f of theta squared. Okay, that will be sine squared then. If f of theta is sine, and they want f of theta squared, that's sine squared. And then they want me to plug in 30 degrees. And what's the sine of 30? Go to the unit circle, it's a half. So that's a fourth. We all good? Onward we go. All right, so number 25. They want me to do FH pi over 6. Like that? What does that little floating circle in the middle mean? Do you remember?
F of H.
Composition, yeah, one function in the other, so it means this. It means put the whole h inside the f, plug one function into the other. Like that. Good to there. So that little floating zero means compose them. Put one inside the other. Like a music composition puts together the different instruments into one piece of music. Okay, so how do we do that then? Well, what is the h function? Well, right here it says the h function is 2x. So that'll be 2 times pi. So I do the inside first, do the h first, and that says just 2 times whatever you plug in, right? That's what the h says here. It's just 2 times whatever you plug in. So that would be, and how do you do 2? Put 2 over 1, 2 goes into 6 3 times. F of pi over 3, good so far. And now, what is the f function? Cosine. So that's cosine of pi over 3. Cosine of pi over 3, if you go to the unit circle, I believe it's a half. All right, want to go see. Cosine of pi over 3 is right here. Cosine of pi over 3 is a half. And there we go. Are we good with that? That making sense? Questions I can answer? All right, so just tracked it through, right? Did the inside first. The h function was double whatever you have. I did that, and then the f function was cosine. So let's try this one. So f of pi over 6. So in this case, so part A, f pi over 6. F is the cosine function. So this just becomes cosine pi over 6. If you go to the unit circle, it's square root 3 over 2. Cosine pi over 6 will be square root of 3 over 2. Okay, that's the first one. And then they say, what point does that mean? Now, what do they mean, what point? Do you understand what they mean by that? They mean like x, y. So when they say 1 point, they mean like an x comma y point on a graph. Well, how do you know that? Well, remember, x is what you plug in, y is what comes out. They're just making sure you remember that. Whenever you deal with a function, whatever you plug into the function is x, and the answer that comes out is y. Remember how we always say y equals f of x, right? X goes in, y is what it equals, what comes out. Whether it's right side or left side doesn't matter. On the y, it's just what comes out. So what goes in is x. So they're just reminding you, hey, they're kind of bringing in function notation and just keeping that before our eyes. Just saying, do you remember how function notation works? Whenever you plug into a function, that's x. What answer comes out, that's always y. So we're saying, okay, I plugged in pi over 6. That's my x. I got out root 3 over 2. So that would be a point on the graph. That'd be the x, y on the graph. Okay. Then part B says, using results, what point is on the graph of the inverse? So what point is on the graph of the inverse? A point again, so again we want like an xy kind of thing. So this is the point on the regular graph f. This is the xy, xy on the regular graph f. So what happens for an inverse?
Why don't you just take the adjacent one across it?
We flip them. X and y flip roles. That's what an inverse function is. X and y invert roles. Yeah, so then the x would just be the root 3 over 2, and the y would be the pi over 6. That's what an inverse function is. Remember how when we find inverse functions, we switch x and y, and then we solve for y? That's exactly what an inverse function is switching of x and y. Switched them. Good there? So that's all they want for part B. Now part C, what point is on the graph? So I have to, if you got that down, I'll move to a fresh screen, or maybe I could just squeeze it in over here. So part C is saying what point is on the graph of y equals all that? I don't know. Get rid of this here. Okay, so let's try that. So part C, f of x minus pi over 6. Oh, and there's a minus 4, yeah. And they're saying x is pi over 6. So they want me to plug in there pi over 6, don't they? So that would be pi over 6 plugged in for x. And so it's f of 0 minus 4. So far, so good? Now, what's f of 0? Well, what is the f function? Oh, up here. F is still what it originally was. It's cosine. So this is cosine of 0 minus 4. Makes sense how I'm tracking this through? Cosine of 0 on the unit circle is 1. 1 minus 4, negative 3. Oh, and they said what point? So again, they want x, y. So the x is what I plugged in. Wait, going too fast? So this is the answer, which means this is y. Remember, what comes out is always y. What did I plug in for x? Pi over 6 right there. So I plugged in pi over 6. I got at the answer y, negative 3. And there we go. Questions on that one? Tracking through all that? All right.
No, not yet.
Physics is great fun. Well, it's challenging. Physics was the hardest thing I did in junior
maybe
college.
General physics. I don't know about the other physics.
All right, so they want me to do the R, so I'll just simply write out the R formula, which is V0 squared sine 2 theta over G. And just plug everything in. So what's V0? Well, it says up here, a lot of times I'd read physics questions when I took physics like this, and I'd be very confused. And I learned to just pay attention to the little units and the little words. So I go, okay, I need a V0 here. What's V0? Well, right up here, I'd say initial speed. Can you read that? V0 is initial speed, and they go, oh, initial speed 190. Ah, that must be V0. Right? So that's 190 squared, because V0 squared. Sine of 2 times theta. Now, what's theta? Well, that's got to be the angle. 35 degrees. Over G, what's G? Right here, 9.8. What's that G stand for? Gravity, the force due to gravity. So 2 times 35, this is 70 degrees. So let's just hit the buttons on your calculator. 190 squared times sine 70 over 9.8. See what we got. I'm getting 3461.52. I don't know how, rounded 2 places, yeah. 3461.52. Did y'all get that?
Does my calculator have to be in degree then?
Yeah, gotta be in degree, because that's a degree angle we're plugging in.
Oh, mode. My bad.
We good? Anybody else getting that?
Yeah, I got it.
Good.
Wait, the what? Yeah.
3461.
Same for each.
Yeah, and the second part is the same thing, just plug into the H. So what we found is if you shoot some projectile at 190 meters per second at an angle of 35 degrees, that's how far it'll go. So with those physics formulas, you can figure out how far things go. And then the height will be the H one.
Will there be one of those in the exam?
Anything in the homework's fair game, right?
That's just evil.
I would give you the formula, though. You won't have to memorize it or anything.
9.8.
Yeah. On that. Good. What's the best? If you want to maximize distance, what angle should you shoot at?
Straight up.
Straight up. Straight up and down. I don't think we maximize distance that way. 45. Yeah, 45 is the best. You can prove it because if you plug 45 in here, that's sine of 90, which is 1. So that'll make that as big as possible. That's the maximum value of sine. Highest is 1, lowest is -1. See how I know right away? 45 degrees will make the sine 90, 2 times 45. Maximum value of sine. 45 is the best angle. If you want maximum distance, that
90
is.
is the best.
All right. So there we go.